So I'm not going to question too much those who said 50 bugs per line of code. I don't know what you put in production, but let's get started. So in this talk, I want to talk to you about how you can go towards bug-free code, how you can optimize your code base, how you can make it more robust so that you put less bugs into production. So just a quick intro. This is me. Yes, I've got curly hair here, straight hair here, always confuses people. I've been working in the development sphere for about 5 years now. I spent 4 years as a full-stack developer, and now I work as a senior data engineer. Big change. Yes, I wanted to try something new. Fun little fact is I've lived in 6 countries and moved 8 times before I turned 18. And if you couldn't tell by the name, I am French. My French accent will come and go. So don't mind it. So, are bugs really that bad? So that statistic we were talking about, 1,000 lines of code, is what we usually use to measure how many bugs you introduce. So on average, a developer actually creates 70 bugs per 1,000 lines of code. That's quite a lot, but be reassured, those that actually go into production is only about 15. So you get about 15 bugs per 1,000 lines of code that end up in your customer's hands or your client's hands. Okay, that statistic, yes, numbers, bugs, great, but what does that mean as a developer? So what you'll find is actually fixing a bug takes 30 times longer than actually writing that line of code. You're spending that time debugging, trying to figure out what's happening. Even just replicating the bug in the first place will take you some time. So it is costly both for your client's trust, but also for your own time. And that impacts snowballs. So all these bugs, all this time spent means that you get stressful releases. Who has ever had a very chill deployment to production where you've pressed the button and had no stress? Oh, there's a few. That's good. I think you have robust code. But for the majority, people are usually quite stressed when you go into production because you don't really know. There's just that anxiety, and often it's because you think there's a bug that's going to happen. So you get more stressed. Frustrated clients, understandably, they see a bug in their product, they're not happy. Loss of trust. When the quality of your product is less good, people will go towards your competitors. They won't want to use your product because they'll think that more bugs will come into play. Frustrated team, of course, the people who are building it. When you're actually building something and you see all of these bugs, it becomes very demotivating because you want to build something good, you want to bring out those features. And once you see that there's bugs everywhere, that can be quite frustrating. Context switching, if somebody suddenly tells you there's a bug in production, fix it, you're not going to tell them, wait 2 days for me to finish this ticket, then I'll go fix it. No, you kind of have to switch over to it, fix it, and then come back to what you were doing. It means you really need to just remember all that context, which again makes you lose time. And all of this leads to loss of revenue, both on the client and customer side, people no longer liking your product, going away from it, but even from your team. If your team is unhappy, they're going to leave, they're not going to want to work for you. So there's kind of that duality that happens. And you end up in a pretty tough situation. I don't know how many people have seen Ice Age, but I agree with this. It's basically, you're there fixing all the bugs, and at one point, they all come undone, you really start to stress out, and yeah, you're trying to basically plug a lot of bugs that are coming in all the time. So how do most people solve their bugs? I've seen this a lot. If you do it this way, you're not alone. This is what the majority of people do. Someone reports it. Somebody tells you they found a bug. You replicate the bug. This step, not always as easy as you think, because you have to have a very specific set of environments to be able to replicate that bug. You then debug it, a lot of it, figure out what's going wrong. You fix it, and you're done. Right? You're done. The bug's gone. You don't need to do anything more with that. Well, what actually happens if you go through this very simple process is you fix that one bug, similar bug will come back again. Different part of the code base, same type of bug. And again, and magically, it's happened twice. So that bug, if you just go through the system of fixing it every single time, it will happen again. Maybe not in the exact same spot, it will happen somewhere else in the code base. The bigger your code base gets, the more likely it is to happen again. Does this actually happen in real life? You might be telling me that Chloe, you're giving all of this theory. Does this even happen? Like, why are you telling us this? It did, and it only did a few months ago, actually. So there was a client who was very frustrated for something that is understandably frustrating, but can sound quite simple. The spelling was terrible. This was a client who wanted their website in multiple languages, and so the team only spoke one of those languages. They kind of trusted the translations of the other. And the spelling was absolutely terrible. There were lots of errors that were kind of being fixed as they came up. Of course, the client then says, well, I complained about this last week. Why am I finding it this week again? Not the same translation problem, somewhere else in the code base. So it was kind of coming up all over the place. Why does this keep happening is the statement that you end up getting, because these bugs, if you don't do something more drastic, they're just going to keep coming back. Something like this won't work. You're going to fix it in one place, it's going to come up somewhere else again and again and again. So, can we actually get rid of bugs like these forever? Well, we can get pretty close to it. Never say never, but we can get pretty close to it. Bug reporting has been around for a long time. I don't know if you've seen this image. Most people who talk about bugs usually see this image as the first reported bug. So the reason why it's called a bug is because there was literally a bug in their system that broke their system. They even taped it to their little journal when they reported it. Sorry, I just like this little anecdote, not too much to do with the talk, but it was quite fun. And yes, you could theoretically just tape that bug into a little notebook, but there's a lot more sophisticated ways to go about it. Now, the way that you format it yourself, the way that you report this bug, the way that you make sure it doesn't come back again, will of course depend on which industry you're working on, like the format of it. But at the end of the day, the methodology is the same. So what I want you to try and understand is more the why behind it rather than remembering the exact steps. So the main kind of inspiration for this was from this book, which was actually written by somebody in Toyota, and that's what the name Dantotsu comes from. So if you do read it, it's very industry focused. So if you're interested in the manufacturing of cars, go for it. Otherwise, I'll just give you the brief summary. The aim is always the same. At the end of the day, this is what we want. We want to have fewer bugs, and we want to detect them earlier. What do I mean by detecting them earlier? In general, your stages of your features are split into 5 categories. You've got your local development, so this is on your own laptop. If you create a bug here, nobody needs to know. It's in your laptop, never gets out of there. It's in your local development. B is your development team. So these are the developers that you work with, your tech leads, anybody who's still part of the development team, but they're the ones who found it. So this often happens when you're doing code reviews, when you're doing functional reviews. That's when bugs could be identified as well. C, validation, a bit more serious. This is where if you're working with, for example, a product owner or maybe a QA team, somebody who's doing the validation, it's left your development team and it's them that have found the bug. Now, the big 2 at the end, those are the danger zones. D, production. So it's made it all the way into production. It doesn't matter if it's you who's detected it, somebody on your team, or anybody else. Once it's in production, it's classified as a debug. And finally, E. This one's the big no-no. It's the customer complaint. When somebody has seen that bug, gets frustrated with it, and it's E. I've got to say, I was flying with a particular airline when I came here. I found a few E bugs on their website. Very frustrating. So the idea is you want to go from something like this. So here you can see the number of bugs detected at the different stages. So often people have, if they're not building a resilient system, they'll have a lot of C bugs, quite a few D bugs, etc. And you want to move towards something like this, where developers detect it on their own laptop in the safety of their laptop. Nobody needs to know it's detected nice and early on. How do you do that? Good question. First step is that you make sure you understand the problem. Now, you might be telling me, of course I know what this bug is doing, like I know what's happening, but oftentimes you might not be digging deep enough. Firstly, do's and don'ts, identifying the bug. Always try and understand it from the user's perspective. The funnest kind of Dantotsu I've seen is where somebody copied and pasted the logs from the back end. The ones where it's like all the import error or cyclical things, which like are 50 lines long, but really should be 1 line. Yeah, those ones. Somebody pasted that in, very hard to understand. And it's good to show what you're expecting versus what you're getting, because then you have a better understanding of what is the difference between what you should have and what you do. Now, the don'ts. Don't write a very long paragraph explaining the defect. This is something people are often tempted to do because you think you're going to give more information by writing all that text, but it makes it difficult to understand, and also you're biasing them because you're explaining to them how you think the bug behaves, how you think the bug has been introduced. And so that gives quite a lot of bias. And also don't assume that everyone will have the context. Now, why am I saying this? Is because making sure that bugs don't come back into your system is a team effort. Because sometimes you'll have the answer on how you can do it, but a lot of the time you're going to have to ask somebody else for some help, pool all those ideas and make it more resilient. So make sure you don't assume that everyone is going to have context. Now, that long paragraph, I kind of want to prove to you why you shouldn't do it. So, why avoid text? Option 1, you got this. If anybody is paying attention after line 2, I am impressed. If you've read the whole thing, there's a spelling mistake in there, try to find it. Option 2, a picture, okay? This is the bug that the client was talking about when they said translations. There's an extra S at the end. Now, if you wanted to summarize it into one line, there's an extra S. Much easier to tell that with the second one than with the first one. So picture tells 1,000 words. Try and communicate through images because that makes it a lot easier. Step 2, explain with code the technical cause of the defect. So now you have the visual illustration of what's going wrong. We now need the technical explanation of what's going wrong. So do solve the bug. That's the point. Do solve the bug. Don't wait for your client to be frustrated. If you tell them, hang on a second, I need to spend 24 hours doing a Dantotsu before I fix this e-bug, they're not going to be very happy with you. So do solve the bug. Don't wait for the client to be frustrated. Now, when you are trying to explain what's going wrong, it's good to, of course, have your code diff, but make sure you only include relevant code. If you're writing 100 lines of code, again, people will not focus. They won't get the key points. Try and keep it short. 20 lines of code, amazing. Try and have a little explanation in it. Don't worry, I'm going to give you an example of this. I'm not just throwing this at you. And also don't link a PR for the same reason as not putting 100 lines of code. It's going to make it difficult for people to understand. For our case, this is very simple. I'm sorry to say it's not always this simple, but for our particular bug, it was. Simply remove the S. Magic fixes it. Great, okay, we've removed the S. I'll give you another example later, which is a bit more complex than this. But here the point is, I'm hoping everybody in this room can actually see how the bug was solved with just a few lines of code. So again, it's giving you context. So why am I talking about setting the scene? Why do I keep talking about giving context? Like, what's the point in actually describing the bug properly to someone? Well, firstly, you won't always have all the answers. You want to use the expertise of those around you. For example, there was one point where I had a big Terraform problem. I wasn't necessarily a Terraform expert. I wanted to go ask somebody for help. If I spend 30 minutes explaining what's going wrong, I don't really want to go and ask for that help to keep going. But if it takes me 2 minutes, I can be like, this is the bug, this is what went wrong. It's a lot easier to go to the funner part of the discussion, which is, how can we make our system more robust? So having a good explanation makes sure that you can use the expertise around you. Secondly, it actually helps you look from a different perspective. When you write things down, you think about it a bit deeper, especially when you're thinking of it from the user's perspective, or you're trying to make it more understandable to other people in your team. So it gives that other perspective that might mean that you find different answers than the first time around. And as in life, before you dig into why, it's good to understand the what. Otherwise, you might get the wrong answer to the why, quite simply. Okay, we've done the part of describing the problem. Let us actually analyze it. So when we analyze it, this is where we get into the point of we want to eliminate this bug forever. We don't want to have it in our code base. We want to make our code base super robust. This never happens again. Step 3 in the whole process is, why was the faulty line written in the first place? Like, why was somebody actually able to write the code that introduced the bug? Okay, a bug, I think people will use different definitions for a bug, and I don't want to start the debate today about whether something can be considered a bug, a feature, an improvement. Let's just say that for now, a bug is that your code does not work as intended. So if you have a bug, it's equivalent to someone didn't understand something. So there was a knowledge gap somewhere. It could have been a communication problem. It could have been something was unclear. It might even be just like a technical learning that somebody wasn't aware about. This is not a blaming game. It's not saying you don't understand this, because even if, for example, if I didn't introduce the bug, somebody else easily could have. So it's not about blaming anybody. That's not the point of this. It's about what have I learned that I can then teach other people so that they don't make the same mistake. So in our case of translations, it was more of a communication problem. So there were copying and pasting issues, there were translation texts were put into Discord rather than a ticket. A lot of it was more of a communication issue. A technical issue looks a bit more like this. So here we've got a more in-depth example. I can't give you that little screenshot of the bug because of NDA. Fun bits with consulting is like you have a lot of NDAs. But the root of it is that you would get an error saying you don't have permissions to write to a table. So any AWS fans will recognize the DynamoDB name, but the issue was you didn't have permission to write to a table. Code, not too interesting, not too important. The problem is just that await raffle user.update. So here we're trying to update a table in a separate package than where the table was created. And that was meaning that you had that permission issue because package A did not have access to package B. So we dug into it a little bit to try and understand why did somebody write that raffle user.update. And what we found is that the team did not follow basically good DDD, domain-driven design architectural practices. They didn't really know about domain boundaries, so they didn't realize that there was going to be this permission issue. Great, that means we can teach them about it, we can have some training about it, make sure that any new junior developers are taught kind of the same type of practices. So that's all great. Knowledge gaps, training, very interesting stuff. But there's also the fact that the faulty line was detected so late. So this one was a debug. It was detected quite late in the flow. So how can we make sure we detect that earlier? So that's the whole point of this. We want to make sure that we detect it as soon as possible. And we don't want this to be, like a checklist. Remember to do this. Remember to check this. That's not going to be very robust. We want to make it physically impossible for someone to deploy code, to merge code, which has these types of issues. So having those robust barriers. Now, sometimes people will automatically say, tests. Tests are the way to go. I'm going to put tests in my CI. Well, if you didn't realize that this was going to be a mistake in the first place, you might not have written a test for that in the first place to begin with. So again, it kind of falls under the checklist item, which is not super robust. Don't get me wrong, tests are amazing, but they're not kind of the most robust solution that you can have out there. So this is kind of what you want to have. Imagine you have a European plug and a UK plug, and you want to make it physically impossible for the match to happen. So that's what we're trying to do with our system. In this case, my translation error, I want to make it physically impossible for someone to have that wrong translation, have that leftover S in their code. So when we looked at this a little bit more, we thought, a lot of this is basically throwing ideas out there, and then one of them will stick. So the first thing we said is, we have messy translations. Some of them are unused, some of the text hasn't been extracted, it's incomplete. That's the first thing we noticed. The second one is this was part of a really big code review. So there were thousands of pieces of text that needed to be extracted. It was quite a big code review. And the third one was, well, I don't know if you spotted this when you first look at this image. It's really difficult to see that literal string in the IDE, that little leftover S at the end. Okay. We thought, well, these two other ones, definitely interesting. But this one, especially when somebody said IDE, we were like, okay, how can we make it easier for somebody to notice that they've left over that literal string in the IDE? That's when we get to the countermeasures. So the countermeasures is, what do you need to change in your system? What do you need to change in your environment to make it more robust, to make sure you don't do it again? So 2 key points about countermeasures. They need to be local to your team. If you have to involve 20 people to make it happen, it likely won't happen. It needs to be actionable. Again, theory is great. If you're not going to put it in place, your system's not going to change. And that's how you get these common mistakes as well. If your whole team does not agree to make this change, then it's not going to happen. People aren't going to be motivated. It needs to be something that everybody agrees with and think it's going to make a difference. Also, if the actions are too big, again, it's not going to get done. If you go from 0 tests and you say, I want 100% test coverage, very difficult to convince anybody to spend that amount of time for a small bug. So it needs to be incremental. And finally, if you have no owner or check date, once again, it's going to be left in the backlog. It's not going to get done. So the idea is, once you have this countermeasure, you try and implement it within a week. You basically try and implement it as quickly as possible because you don't want these bugs to keep coming back. So in our case, when we said this little string at the end, I can't really see it, well, only about after 5 minutes of research did we realize there's an ESLint rule for this, which literally says no literal strings. It takes a single line to put it into place, and voila, you can't put any literal strings anymore into your code. So all these kind of struggles that the client was saying, where there was mistranslations, text was not being translated, etc., easily solved with a single line of code, which basically implements that ESLint rule saying no literal strings. It's really that easy once you spend that time to think about it a bit more. Now, the second one is more of like the little fun one, is because we noticed there was a lot of unused translations, you can easily just add a script in your CI that kind of looks at all your translations, looks at your documents, and says these ones aren't used. So it's kind of a nice little tidy up. Also, when compared to kind of the feature work tech improvements, if you tell developers you can write this really cool script that not a lot of people have, there were a lot of takers. You're definitely going to motivate your team for something quite fun. So I've kind of just spoken about a linter and a script, but there's lots of things out there that you can actually implement within your code base that's going to make it more robust. So things like dependency management, infrastructure as code, linters, type safety, testing still there, automation. There's so many ways that when you just stop for a moment, look at your bug, look at how it was introduced, you're actually able to tell, okay, if I put this in place, I'm not going to get this bug again. If you don't have any ideas about it, Gen AI is actually quite good. There have been times where I've literally used that, remember the starting analysis, like understand the problem? I've thrown it at ChatGPT and it gave me like 3 new ideas to make sure I don't implement this again. So that's also where phrasing it is very important, because you can use tools that you have out there, you can use people that you know to make sure that this doesn't happen again. Key things to remember. So do dig into your bugs more than just fixing them. Don't just fix them and leave them as they are. Spend some time to actually understand how it was put into place and how you can make sure that it's physically impossible for somebody to write that line again. Do involve the rest of your team. So if you want to build a resilient system, it is a team effort. You're kind of using their expertise as well as your own, getting people more motivated, and then they're also, prouder of the code base that they have built. Now, this one's a tricky one with the third one, because sometimes you can tunnel quite quickly and you can spend hours and hours trying to find a solution. As a rule of thumb, don't spend more than 30 minutes. If you're tunneling after 30 minutes, involve somebody else. Try and speak to somebody else to try and help you find that solution rather than tunneling for 3 days. Fourth, don't blame yourself or anyone else. This exercise is not a who did what, let me go and find that person. It's very much a what happened and how can we make sure that we all learn from this. And last but not least, make sure you don't have vague countermeasures that you're not committed to. If you're not committed to do something, it's not going to happen. So that one's quite important. That was everything. So please don't forget to rate this talk and feel free to come chat to me afterwards. But otherwise, thank you. And if you want to connect, that's just the little QR code.